So the next example, I will show you something which is not possible to do in Rhino, or at least very, very difficult. What I'd like to do here is generate a pattern of circles, and I want to control the radius of every circle. And that radius is going to be steered by a bitmap image. So if it's a dark pixel, it'll be a small circle. If it's a bright pixel, it'll be a big circle. So we'll begin by making a bunch of points, a grid, and just having a bunch of fixed circles on each point in that grid. Once we have that, we can import a bitmap and actually sample the image at these point locations and get the brightness of the pixel underneath that location. And that brightness will then be a guide for our circle radius. So we'll start off with a brand new document. I will hide this geometry. And let's make a grid first, so we can actually see our options for size and extent. And you could make a grid by using math operations. There's also a grid component directly available. If you go to vector grids, there is hexagonal grids, radial grids, triangular grids, and square grids. And we'll just use square grids for today's exercise. Now, by default, it already has all the values set. So there's a plane for the grid, which is the world XY plane, and which is previewed right here. And I can change this plane. I can go in and say set one plane and actually pick a different one. So I can go in here and pick a new plane origin, pick a new plane direction, and plane orientation. And now the plane is actually at an angle instead of the world XY direction. But let's undo that, go back to our flatness. It also has a default size, that's 1 by default, and it indicates how big each cell is in width and height. And finally, there is a number of cells in both X and Y directions. And I'd like to make it a bit bigger. I'll go to 20 cells in each direction. So I'll overwrite the values in those menus here. So I can open up the EY menu and overwrite the default of 5 to be 20. And now I have a grid of 20 by 20 cells in both directions. So it's a lot bigger. This component outputs the cell outlines, so it's a bunch of rectangles, and also the points at the corners. But it doesn't show the points because there might be so many of them. So if you want to see the points, you can make a new point parameter. So drag a new point parameter from the toolbar onto the canvas and share the data. And actually it will show all those little point processes on the screen here. And in fact, I don't want to see the grid at all. I just want to see the points. So I will hide the grid component. If you select it, you can click on the blindfold icon in the toolbar, and it will switch the preview off for the entire selection. So when I hide it, now we're left with just the points in the viewport. Okay. The next step here is to just make circles on these points, and we can make them all the same size to start with. So let's have a look at the curve tab, primitives panel, to see which kind of circles we can make. With a circle, we just define by a base plane and a radius. There's a circle from 3 points, a circle from a center point, a normal vector, and a radius, and even a circle which is inside a triangle. So those are the 4 options we have here in Grasshopper to make circles. And I'm just going to use the circle from base plane and radius and see what that actually gets us. This takes a plane, and the default is the world XY plane, which again you can see over here. And it takes a radius which is by default 1. And as you can see, the circle here has a radius of 1, which is the same size as our grid cell. So it actually touches those 2 points. Now I want to change the base planes for all these circles. So instead of using a single plane, I want to use these points as center points for all my circles. And I can just share this data from the points the input. And this will actually generate all those circles based on all the points. Now, you may have noticed that what we have here is points, and what we need here are planes. But when you feed points into a plane input, it will generate a plane at that location which is parallel to the world XY plane. So points to planes will word in Grasshopper. And the same is true of planes to points. For example, if you have a plane and you need a point, it will just take the plane midpoint. And if you have a flat curve and you need a plane, it will create a plane in that curve location. So it's all quite flexible here. So now we go from points to planes, and we get these flat circles. Now you can see that they're actually way too big. One circle has a radius of 1, which means it spans all the way from this point to the next point. If I change the default value of 1 to, say, 0.5, we get a collection of circles that are actually touching at their midpoints here. If I make them smaller still, 0.4, they'll become separate, but let's stick to 0.5. Okay, that was the easy bit. Now for the hard bit. We want to sample an image at all these point locations. And I have an image available here. It's a PNG file, which is available in Windows Explorer here. So I'd like to import this image into Grasshopper and sample the pixels at the correct locations. I can just take this image and drag it from Explorer into Rhino and Grasshopper. And when I move over Grasshopper, and I'm still dragging it, let go, it'll actually generate a new image sampler object linked to that image here. And let me hide all this stuff, because I'm going to explain where this image is. When you sample an image, the default size of this image is 0 to 1 in a world space. So this image actually exists inside this one grid cell. And just to show you that in the screen here, I can use a picture frame to show you the image in world space. So this image exists in this size and this location. And it's tiled also, which is the default. So in fact what you have is this image repeated from here to the edge of creation over and over and over again. So if I sample a point somewhere along in this space, I'll get black, white, 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 black, 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 white, 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 and so on and so forth. If I wouldn't tile the image, if I, for example, clamp it, then it only exists once, and it only exists within this one cell here. And if I flip it, then the ones over here are not like this, but they're mirrored along the direction. So you have those three options to deal with images. They're either clamped or tiled or flipped. Now this is a bit of a problem because my grid is much bigger than my image. My grid is actually 20 units to a side, whereas my image is only 1 unit to a side. So I need to change this image to go from 0 to 20 along both axes. So I can scale it from here, and actually I have to make sure it's this big. That big. I can change this image size through the image sampler here. If I double click it, it will open up the image sampler settings. And here you can say the X domain and the Y domain, and they're the default 0 to 1. And I need to change this from 0 to 20. And as I change it, you will see that the tags on the preview also change from 0 to 20. So now we have an image that's actually the same size as the grid here. Furthermore, you can change the tiling here. Again, there's two options, clamping, tiling, flipping. And you can change how the image is sampled. By default, you sample colors. But we actually want to sample not colors but brightness. So we have colors, red, green, blue channels. We have transparency. We can sample hues, and we can sample brightness. I'll change to brightness sampling, and this should be it for our image. This is just our correct size and the correct sampling method. You can either open a menu inside the image sampler and choose settings, or you can double-click on the object itself, and it will open up this dialog. Usually, when there are settings to an object, you can just always double-click it, so that this works for the image sampler. This works for number sliders. If you double-click it, it will open up this window. This works for text panels. If you have a text panel, you can double-click it and actually change the text inside of it. So all these things are always available through shortcuts like double-click. Now, this picture frame is just an image here to show you where this image is in world space. So it's not actually used at all, and I can hide it here. Oh, hide it. So what's left to do here is to sample this image at those red crosses. And that's luckily as simple as just dragging the points into the image sampler and using the outputs, which should be a brightness for every point, as a radius input. And if I switch my circles back on in the preview, you will see that there's now circles which are tied to this image over here. But they're still too big, because brightness goes from 0 to 1, 0 being black, 1 being white. And our radius was allowed only to be half before it actually hits its neighbors. So we need to actually post-process this brightness value and scale it from a 0 to 1 range, which is what we have now. So if I run through this list here of brightness values, you'll see that there is a lot of black, then there's a little bit of very, very dark gray down here. And as you move over, there's more light gray, and eventually you should get very close to 1, which is almost entirely white. So just over here we have an almost entirely white pixel, and here we have a completely white pixel. So this range from 0 to 1 is too big. It has to go from 0 to half. Now we can do this in a number of ways. We could, for example, limit the radius to a specific size. Right? I could say the value is allowed to change, but when it's bigger than 0.5, we'll just trim it off. We'll clip the value. So we can use a minimum component to find the lowest number between the brightness and a constant, which is in this case 0.5. Or even better, it can be a slider. So now we post-process this value, and when the brightness is bigger than half, we ignore it. We limit it to a half, and as I change the slider, you can see that it makes all the circles smaller and smaller and smaller, or bigger and bigger and bigger. The other option is to multiply the value with a half, so that all the radii are actually changed. So instead of having the minimum, we can have a multiplication of our actual brightness times a vector which controls not just the big circles, but all the circles are now changed. So if I set this to a half, it actually generates this pattern here. I can scale all the circles up and down. So if I at some point decide to increase my grid to go from, say, a cell size of 1 to a cell size of a half, and actually sample at not 20 but at 40 locations, I can go in here and change this limit to 0.25, and now I have a new limit for all my circles here. Of course, the best thing would be to actually measure the size of the grid, and using the measurement to control your limits, but that's a bit beyond today's scope. So I'll just use the constant here and change the constant by hand. Okay, before I move on, are there any questions, Mary?
Yes, David, a few. I just want to say that if we don't get to your question, we will follow up with an email in the next day or so. So most of the questions, are what you are covering.